Hi friends, this is Meha here. Hope you liked my earlier videos. Today I'll be telling you about theorems of polynomials. Firstly, let us talk about what are polynomials. Polynomials is a word which is used when there are 4 or more number of terms in an expression. It can also be used when there are 2 or more terms in an expression. Yes, polynomials is said to be a series of terms that are connected by arithmetic symbols, which are addition, subtraction, and multiplication, division symbols, right? So here I have given you a couple of examples. They are x square plus 3x square plus 3 and x to the power 5 minus 3x square and so on. So now let's see about the theorems of polynomials. There are two main theorems of polynomials to find the reminders. They are remainder theorem and factor theorem. They can also be obtained by doing the long division, but it has a long process, so we people don't actually prefer to do it. Instead, we prefer to do remainder theorem or factor theorem to find the polynomials reminders. Yes? Now let's see about the remainder theorem. Let p of x be a polynomial which is greater than 1 is a real number if p of x is divided by a polynomial x minus a, then the remainder is p of a. We have to take p of x as a polynomial. It should be greater than 1 and it should be a real number. If p of x, now p of x is a polynomial. If that polynomial is divided by another polynomial x minus a, then the remainder should be p of a. It is not necessary that the polynomial that is being divided should be only x minus a. It can also be x plus a. Yes, now let's see an example for it. Here they have told us to find the remainder for the polynomial x cube plus 3x square plus 3x plus 1 when it is divided by x plus 1. Here our divisor is x plus 1 and our polynomial is x cube plus 3x square plus 3x plus 1. Now we have to equate that in such a way that x plus 1 is equal to 0. So we have x is equal to minus 1. Because when plus 1 moves from LHS to RHS, the sign changing occurs and so it becomes minus 1. Now we have to substitute minus 1 in the places of x. So our equation will be p of minus 1 is equal to minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. So when we further equate this, we'll get minus 1 plus 3 minus 3 plus 1. Minus 1 and plus 1 is 0 and plus 3 and minus 3 is 0, and so why the remainder is 0. Now let's see about the factor theorem. If x minus a is a factor of p of x only if p of a is equal to 0. Now here x minus a is the polynomial, p of a is the remainder where a is a real number. Now I'll explain it clearly for you people. If a polynomial's factor should be x minus a, then p of a will be equal to 0. If the above situation should be satisfied, then p of a will be equal to 0. So now let's see this through an example. Now here we have to justify or show that x plus 5 is a factor of the given polynomial x square plus 3x minus 10. Our polynomial here is x square plus 3x minus 10. And the factor that is given here to determine is x plus 5. As again we have to equate that x plus 5 is equal to 0, then our answer will be x is equal to minus 5. So now we have to substitute minus 5 in the places of 0. So the equation will be p of minus 5 is equal to minus 5 square plus 3 into minus 5 minus 10. And this will be equal to 25 plus minus 15 minus 10, which is equal to 25 minus 15 minus 10. Now 25 minus 15 is nothing but 10, so 10 minus 10 is equal to 0. So this sum also doesn't have any remainder, therefore this satisfies the factor theorem, right? Because P of A is equal to 0 according to this question. So therefore x plus 5 is a factor of the given polynomial x square plus 3x minus 10, and this is proved by the factor theorem. Yes. Now let's see about the long division. In long division, the denominator is the divisor and the numerator is the dividend, and this is common, we all know it, right? Here the general long division happens to obtain the remainder, but it has some certain differences as the general one. The divisor is nothing but x minus a, or it can be x plus a, and the dividend is the polynomial. Yeah, now let's see this with an example. Here we have to find out the remainder for x square plus 9x plus 20 when it is divided by x plus 5 by long division. Now, the first step to solve this is we have to take the first term of the polynomial or the dividend and the first term of the divisor, and we have to divide both of them. So x square divided by x is equal to x. So now x goes and sits as the first term of the quotient. Now the quotient, that is x, should be multiplied by the divisor. It should be multiplied by both the terms of the divisor. So x into x is equal to x square, and so we have placed it under the first term of the dividend, and x into 5, that is x into plus 5, is equal to plus 5x, and this is placed under the second term of the dividend. And the change or the difference that is between the general long division and this long division is we have to change the sign. Here plus x square should be changed as minus x square, and plus 5x should be changed as minus 5x. And so plus x square and minus x square, when equated or solved, it becomes 0, and plus 9x and minus 5x is plus 4x. Now here our first term is 4x, right? We have to bring down 20 below near 4x, and so the sum will be like plus 4x plus 20. Now our first term is plus 4x. Now 4x should be divided by x, that is the first term of the divisor, and so our answer will be 4. Now this 4 is a positive 4, that it has a plus before it, and so plus 4 will be added as the second term of the quotient. Now the plus 4 in the quotient should be multiplied by both the terms of the divisor. So 4 into x is nothing but 4x, and 4 into plus 5 is equal to plus 20. And now here again we have to change the signs. So plus 4x becomes minus 4x, and plus 20 becomes minus 20. And so plus 4x minus 4x is equal to 0, and plus 20 minus 20 is equal to 0. For this sum also our quotient is x plus 4 and a remainder is 0. So with this we can clearly understand long division. At last, now we have come to an end of this video. Thank you all for your patience to listen to my video. I hope you all will support me by subscribing and liking my channel. Please don't forget to share. Thank you. I'll be back soon with another video. Thank you.